Now we study the intersection of a line and a parabola. Let's consider that we are given a standard parabola with equation y square equal to 4ax and some line whose equation is given in slope-intercept form, that is y is equal to mx plus c. Now with this pair there can be three possibilities as shown. So firstly, the line can intersect the parabola in two distinct points, so we call that line as a secant, or it may touch the parabola in a single point, that's what we call as a tangent, or the line may be neither a tangent nor a secant also, right? So it does not have any point in common. So how do you know which is the case for a given line and a parabola? So for that, what do we do is we solve the two equations simultaneously. So that means putting the value of y is equal to mx plus c in the y of equation of parabola, you see at the end we will get one quadratic equation in x, right? Now being a quadratic, the roots of this quadratic equation will have the nature based on the value of the discriminant delta, right? So if delta is negative, then the roots are not real. That means there is no point common in line and the parabola. That means the line is neither a tangent nor a secant. If the discriminant turns out to be 0, then that means the roots are real and equal, right? So that means the line is a tangent to the parabola. Whereas if the discriminant is strictly positive, then the roots are real and distinct. So that means the line and the parabola have two different points in common. So that means line is nothing but a secant. Okay, so that is how we come to know the configuration of a line with respect to a parabola, right? Now the condition of tangency based on discriminant equal to 0 can be studied in detail as shown. So let us consider what that condition turns out to be. So if we want the line to be a tangent, we start off with the same quadratic equation and considering delta, that is discriminant, to be equal to 0, which is b square minus 4ac in the standard quadratic notation. So therefore for the given quadratic we write the discriminant and finally solve for c. So we get a relation between c, a and m. So if you see, we are given c, a and m in the equations of line and the parabola. So if c is equal to a upon m, in that case we can directly say that the line is a tangent to the given parabola. But remember that for this the equations must be strictly in the standard form as shown here. Okay, so the equation of the line has to be in the slope-intercept form only. Okay, that is only the case when the c will have the correct meaning.